Hi dear students, welcome to Geeta's classes. In this class, we are going to see inverse Laplace transform using change of scale property method. So this is useful for finding the inverse Laplace transform of some special functions. So we know that if L of f of t is equal to f bar of s, then L inverse of f bar of s is equal to f of t. Please remember these things. L of f of t is always f bar of s. L inverse of f bar of s is f of t. And we have already seen Laplace transform of these functions. Please try to remember. All the proofs are available in the previous classes. Please go through them also. And you have to be thorough with the Laplace transform of these functions so that we can find out the inverse Laplace transform easily. Okay. And these are some standard functions, inverse Laplace transform of some standard functions or elementary functions. Please try to remember these functions also. And this is the linearity property. And now coming to change of scale property. If L of f of t is equal to f bar of s, or if L inverse of f bar of s is equal to f of t, then L inverse of f bar of as, that is, if you make some changes in the s domain, what will be the corresponding change which will happen in t domain? That's what is found by change of scale property, okay, where a is greater than 0. So if you multiply s by a, then corresponding, what will be the corresponding changes to be made in t domain? 1 by a into f of t by a. You divide t by a and multiply by, find f of t by a and divide it by a. Okay. Let us do one problem in this. If L inverse of s by s squared plus 1 the whole squared is equal to 1 by 2 into t sin t. This is the given function. Then find L inverse of 8s by 4s squared plus 1 the whole square. Okay. So if there is some change to be made in the s domain, what will be the corresponding change which will happen in t? That's what we are going to find out. So what is given? L inverse of s by s squared plus 1 the whole square is equal to 1 by 2 into t sin t. So writing as in the place of s, what will you get? L inverse of as by as squared, here s squared plus 1 the whole squared. So a squared s squared plus 1 the whole square is equal to, what will be the corresponding changes in the right hand side? According to the change of scale property theorem, if you are changing s to as, then 1 by a into f of t by a. Okay. So 1 by a into f of t by a. What is f of t here? 1 by 2 into sin t. So 1 by 2 into t sin t. So t by 2 into sin of t by 2. Wherever you have t, replace it by t by a. T by a. Okay. Now we have to find out what is required. L inverse of, we want L inverse of 8s by 4s squared plus 1 the whole squared. That is what is required. But so to find, now what is to be substituted in the place of a here? Here if you substitute, by seeing that, don't decide that you have to substitute a is equal to 8. If you substitute a is equal to 8, what will happen? Here it will be a squared in the denominator. That will become 64a squared. That is not required. Okay, we want only 4a squared. So what is the substitution? A is equal to 2. By seeing the denominator, you have to decide, because if you have constant, here you can multiply. Whatever is not there, you can multiply and divide. Here you cannot make the corresponding changes like that. Okay, multiplication and division, it is not possible here. Therefore, put A is equal to 2. If you want, you write equation number 1. In equation number 1, then we get L inverse of A is equal to 2. So, wherever you have A, you replace it by 2. So, 2S square, 2S divided by 4A squared, 2 squared A squared plus 1 the whole squared is equal to, here 1 by 2 into 1 by 2 into 1 more T by 2 into sine of T by 2. Wherever you have A, replace it by 2. Okay. So here we want 8s. So multiply and divide by 4. So 1 by 4. This 4 and this 4 in the right hand side will get cancelled. Therefore, L inverse of 8s by 4s squared plus 1 the whole squared is equal to T by 2 into sine of T by 2. This is what is required. So if there is some changes in S, what will be the corresponding change in T? These kind of problems, change of scale property is to be used. In the coming classes, let us see the inverse Laplace transform of derivatives and integrals. Okay. So please give a like for this class and share it with your friends so that it will be useful for them also. Thank you so much for listening.